my presentation about security for machine learning. So I titled Why Security is Important in Machine Learning and How to Secure Your Machine Learning-Based Solution. So welcome everyone. I want to start with introduction of myself. My name is Rachid Kherrazi. I am CTO at AK in the Netherlands. I have almost 22-year experience, professional experience. I worked mainly for high-tech companies like Philips, ASML, also for some consultants companies like Altran. And the last 4 years I joined AK Technologies. AK Technologies is an ICT company. We have a lot of engineers at clients like Thales, Boeing, so mainly in the mobility, but also in the high-tech and life science and food. Myself, my background is electrotechnique, but I worked mainly in the quality and in, process product improvements. I am an active member of TestNet community in the Netherlands. It's a big community where you can share knowledge, presentations, seminars about general quality testing, test automation, model-based testing, and these kind of things. In that community, I am leading a couple of work groups, especially in security. So I am interested in security in general. And that is the reason I move also to security for machine learning, what is coming more and more important. Another interest area is model-based testing, of model-based system engineering in general. And part of that is model-based testing, how you can use models to generate tests and check quality of systems and products. And another important part is artificial intelligence. I worked almost 2 years now with PhDs doing some prototyping for machine learning and also testing that. So that is a little bit about myself. Today I have the pleasure to share with you security for machine learning. So I will start with a small introduction of artificial intelligence, machine learning, and especially showing the added value of machine learning, artificial intelligence. And then I will move to AI, artificial intelligence application challenges, especially the risks for adversarial attacks. And I will show you some real examples. After that, I will explain what it is, and also explain a little bit the categories, how we can categorize this kind of attacks. And finally, I want to show you also some solutions, how you can take measure against that. And that is part in the machine learning algorithms security, but also in the process technology, but also the mindset and culture. And finally, I will give you some takeaway. So let's start. So I think I'm not, you maybe are more experts than me in this area about the added value of machine learning and artificial intelligence that is applied in several applications, in connective speech, to converting speech to text, recognizing objects, images, translations, decision maker everywhere in our mobile, in our applications, it is applied. And it is growing in the last years. We see that in several applications, several sectors, in the medical, the marketing, even entertainment with recommendations and these kind of things. So that is a growing market. And that is also that this growing market and growing importance has also some expectations from our society, because we think that based on this new technology, we will solve the environmental and economical and social challenges that we have. So there is an increased expectations that this new technology and especially the conversion of these new technologies will help us to solve this economical, social, and the 21st century challenges that we have with sustainability and these kind of things. Definitely, you agree with me, machine learning are generating more and more value. We see that the move from process automation to hyper process automation, a combination of automation together with machine learning, artificial intelligence. We can do more things efficient, fast, and more. So there is a huge, big value generated based on machine learning, and that is also what the reason that a lot of companies are exploring this and want to move to that in the digital transformation. So, yeah, till now everything is good, positive, no problem, but what is the problem now? And the problem is that as part of machine learning is a part that a lot of people, at some reason want to avoid or are not interested for now, but we should do that. And that is what is called adversarial machine learning. And adversarial is coming from the security, the people who are involved in security, they know this term. That means that machines or people or hackers that are trying to manipulate systems or software in such a way to create backdoors or attack or lowering the performance or stealing information and these kind of things. And that is the source where this adversarial machine learning attack terms come from. So let's start with some real examples. I just picked a couple of them here. For example, the first one is the well-known video decoder called YOLO. They discovered that just based on some putting on the front of the screen some extra pictures, the algorithm was not able or was manipulated to not detect persons. So that was, a manipulation just based on adding something on the screen. The algorithm was failing to do the right job. Another example is the Microsoft chatbot toy. In 2016, the attackers was able to manipulate the chatbot in such a way that was generating racist content, and Microsoft finally shut down this application. Another example for the automotive by Tesla, Autopilot in 2022. Based on just a small manipulation on the traffic board, the algorithm was failing, of the classifier was failing to detect the right job, let's say. Instead of 35 speed, they think it is 85. And that was also a big impact because they need to change that to improve that. And they discovered that just by small changes, because of that was not correct tested or not, the measures was not in place to avoid these kind of small mistakes. Another one is in 2017. It's the same here by just small changes for the stop sign. The algorithm was thinking that it is a speed sign. And also here, they changed and they improved it. This is just a couple of examples. And this is not limited to only vision, because in the previous, except the chatbot from Microsoft, it seems that it has to do with vision, but it's not the case. This kind of attacks are not limited only to vision, but also to speech and text. Another example for vision here for the medical deep learning system was failing to identify diseases, just to add some noise in the image. For speed, the automatic speech recognition was also failing to perform the right job just by adding some noise in the background. And also for text, for NLP, this classification just based on some manipulations, the attackers was able to change the performance and the correct working of these NLP algorithms. So the message here is that it is not limited only to vision, it is everywhere. And even here I used the most standard classification of several machine learning approaches from reinforcement learning. We have some attacks there. For supervised classifications, regressions, you have also some attacks. Unsupervised machine learning with clustering, association, but also dimension reduction. In short, in every kind of machine learning, you can expect this kind of attacks from hackers. They are working on this. So be aware that this is more and more an interest area for hackers based on that. There is a nice paper which explains a little bit the history of these attacks, adversarial attacks for machine learning. I think you cannot read it, but I put here the reference. If you Google it, you can find it, and maybe you can find new versions of this within timeline. It is starting somewhere 2004, and you can see all the kind of attacks that is in these different sections that I mentioned you in the previous slide. And the ones of you who followed the session from Alex yesterday, he also showed us some graphs showing increasing number of papers, publications about that. So that's also a good reference to check, especially if you are working in one of the area, then you can focus on that area and check what are the attacks and type of attacks that are happening in that area, and also the new ones. So when you have time, please take a look to this paper. So let's go to the next section is what are the adversarial attacks, and especially we will talk mainly about the categories of these attacks, and to help us to explain what it is. So if you want to categorize these adversarial attacks for machine learning, then you can do that based on the location where the attacks is happening. And with location I mentioned here, is it during the training or after the deployment of the model? And that is also the reason that they have two names. It is called poissoning attack or evasion attack. Yesterday we saw also this kind of terms. Based on the knowledge of the attacker. Sometimes you have in your team someone who share information to the outside world that can be also attack information for hackers to come in, and for that you have what they call white box attacks or black box attacks. White box attacks or gray box attacks. That means that the hacker already knows some information, maybe via someone, or he has some open doors to some information internally of your company, the way of working, and these kind of things. And black box attacks is mainly that the hacker doesn't have any information about the company, the process of the product, but even that, based on some techniques, he is able to make some open doors and hack and lower the performance of your product and these kind of things. Another type of classification is the intention of the attack. Is the intention specific target things in your model, or is it in generic? And I will explain that in the next slide, these three categories. So let's start with the first one, about based on where the attacks is happening. And I forget to put here I come later to the paper where you can find this. It's a very, very nice paper. But you can, from this picture here especially, you can see that if the attacker is able to do that during the training phase, then we are talking about poissoning attack. So that means that a hacker is manipulating the training data or the test data or some processes inside before you are deploying your model. And in such a way that he later can reduce the accuracy or reduce the performance. We saw yesterday also they can manipulate, do something in the data in such a way that maybe the power consuming of your process in deployment will be increased in such a way that you have some performance problems. That can also be. It is not only stealing information or this kind of things, but also affecting the right performance of right working of your product in production. That can be just based on something happening in your data. That is an example. If the attack is done after deployment, then we are talking about evasion. And then the attacker is what he's doing here is the example that I show with just putting in based off his knowledge about how the principle working of this machine learning by adding some text or some objects on the image for vision, for example, they can manipulate or manipulate the correct working of your machine learning algorithm. So these are, just to know, two types of attacks, and based on the location. And third one, based on the location, is also what they called, let's say they try to do reverse engineering by using APIs. For example, if your model is accessible by APIs, they are sending information or trying to interact with your application or your model in such a way that they can reinverse and understand the parameters of your model. If they also know a little bit how the model is built, based on the interactions, they can do reverse engineering, and by that, they can also manipulate and do some attacks. So that is the third one, type of classification based on where the attacker are addressing your model. The second classification is based on the knowledge. I explained a little bit what I told you the black box, gray box, or white box. So I will skip this. The third one is about, is it a targeted attack or not? For example, in this example here, the hackers was able just putting an extra sticker on the close to the object. The algorithm of the classifier here was totally not able to recognize banana. This is a known an algorithm. You can find it. I put the reference here. You can test it by yourself. Another one was also mentioned yesterday by Alex. It is also a targeted attack by adding some mathematical noise to the pictures. The classifier was not able to recognize the panda. And this is also a very known example used in a lot of research papers. Maybe one is also nice to show you here or to explain you, but because it is very simple, the algorithms for handwritten digits, for example. There is a paper about this where they show how you can manipulate that. So, for example, here it is a neural network algorithm. And when you add some noise to the picture, the algorithm will detect the 8 as a 3. And maybe I can explain you that better in the targeted algorithm for 0. If you take a close look in the images here, I don't know if it is clear, at least on the screen here I can see it, but in the Beamer, I think yes, from here I see it. On the background, you see these circles like zeros. And that is exactly what they did here to manipulate this algorithm, to think that a lot of these numbers are 0 instead of the other digits, just by adding that. And a couple of these algorithms are not robust against this kind of manipulations. And just to give you an idea, it is very simple how they did. And maybe you can play if you are building this kind of algorithms. You can maybe also try it yourself and just manipulate a couple of these handwritten things and try to check if your algorithm is robust against this. Just to give you an idea about how simple it is to manipulate your machine learning. And of course, I will come to that later. most time we are experimenting with this kind of new technology. We are happy if it works, and if it works, before we test it, the product owner maybe say, hey, shall we deploy it? Because money, we can make money. And we don't have time to test and to do this kind of things. And before you know, it is used in production, and the hacker are able to steal your information or change, and you have a big problem. And I will come to that later. This is the paper I mentioned. It is called Privacy and Security Issue in Deep Learning Survey. If you Google it, you can find it, I think. It is very easy. But the nice here, I want to close this part of my talk about this nice picture, because it shows, again here the different attacks, what I explained before. So you see here the attack method. So if you do it, maybe I can start with the middle part here. You can see actually the machine learning of process in total here, where you see the physical world, where you get the data, then collecting the data, then you train the data, training the data, then you have the model, and after that you will test the model to test the performance, and then deployment. And on the top you can see the different type of attacks, so positioning attack, model extraction attack, model inversion attack, and these kind of things. But the nice thing is here on the bottom, when you see also the solutions. What are the measures that you can do? So there are several methods explained in this paper, and in the next part of my talk I will explain this couple of them in such a way that you are aware about what you can do to make your model more robust against these kind of things. So let's go indeed to the solutions of machine learning security. I will also in this part explain why it is important. I think you know, but I will again insist, and I will give you some best practices that has to do with this kind of measures, but also because security is not limited only to the machine learning. It is part of the whole story, because you are doing first the machine learning training and testing, but after that you need to deploy it, and then by deploying, you are using standard development process where you need to test, and I will show you that later. So some solutions are also here categorized, let's say, for what we call model hardening, or making a robust assessment to check, but also during the runtime, even after deployment, you can do a lot of things to make sure that if something is happening, you are alerted on time, or maybe automatically take measures to avoid that the risk or the effect is high. So, an example of tools for, let's say, that can be used for hardening the models or measuring robustness of the models, and even detection in real time. One of them is developed by IBM. It is just an example. There is not this. I am not selling here IBM things, but this is just an example that you can use, or you can explore to play with it. It is called Adversarial Robustness Toolbox, and you can do all these things. Just to give you an idea what they do for the robustness test. Here you can also see that indeed sometimes when you are handling data, you don't have time to do this. You are more focusing on the correct working, functional working of your model, and you are less giving attention to robustness or the non-functionalities. This is because this is part of the non-functionalities, the elities for all the products and process. So for example here, what you can do, and we saw the examples for the traffic signs. Most time in your data set, you are using standard pictures. But here you can do some manipulations to check the robustness. So you can play with the brightness of the image. And here in some examples, you see that by just changing the brightness for 35%, the algorithms failing to do the right work. And other things is what they call box attack, is just reducing the size of the images, of playing with the size of the content. It fails. Rotations, just by rotating the pictures, can also have impact on the correct working of, but also adding some noise or water effect in your images. So this is just some ideas that this kind of robustness tools automatically helping you to do this kind of things, extending your data with this kind of information of images in such a way that you can check your model or robustness of your model against these kind of things. And that is also what the hackers are doing. They are just playing with your information in other way, in such a way where they can see, okay, at this level, your model is not working, and then they have an opening to information or altering the correct performance of your model. There is also some tools that are doing this, like Clever Hands, Fullbox, Sec ML, and so on and so on. So be aware that there is a lot of open source tools available that you can use to play with this. Of course, you need to make time for it. But I think, yeah, this kind of training here of talks make you aware about the existence or the availability of this kind of things. So why is artificial intelligence security so important, actually? And it has to do with a couple of things. One of the things is that what I mentioned before, and we saw it yesterday, there is a growing market of machine learning. A lot of companies, because of the digitalization, but also the conversion of several technology trends. So we are combining now machine learning together with process automation. We are doing a lot of artificial intelligence use. So the market and the area of where machine learning is growing, and that makes also that it is new. So there is growing of the market is keeping growing. So there is plenty money used in this market, and that is potentials for hackers. So the market is growing, the money used around this is growing, so that is a good focus area for hackers, and that makes it important that we need to secure our machine learning things. What also is happening is we are combining a lot of technologies. We are more connected, a lot of connectivities, and where we are using also machine learning. So this kind of connectivities is also increasing the attack surface, let's say, of the hackers, and we will come back to later to what is an attack surface. So they have more, because of the complexity, the connectivity, the hackers have more ways to come to you, to your data, to your model in this kind of thing. So that is also one of the reasons that makes security of machine learning very important. And we also see one of the trends is that machine learning is also used for security themselves. So also hackers are looking how they can break this counter attack, let's say, from security. Also the data aspect, that is also a kind of evolution of how we are more connected, we are generating more data, and we are using data for machine learning. So also the data used by machine learning is very important and for hackers, and that is one also of the reason. And in the graph, maybe you cannot read it correctly, but you can see the increasing potential for the data that is used by machine learning. And of course, it is something new. Machine learning, artificial intelligence is new. We are using some algorithms just discovered of developed a couple of years ago. It is not yet robust, not yet used everywhere. So that is a very attractive area for hackers to explore and be first. And that is the reason that it is more urgent to take countermeasures and be aware before you are deploying, before you have a big problem in your application. And other things is security especially is something what is not only for machine learning area, but also in the normal development, even if I am not using machine learning, is something what is not attractive by project managers, product owners. They see it as more slow in the process because you need to do penetration tests, you need to take some measures. So yeah, that is something what is less attractive by project leaders of these kind of things. Also, if you want to do good security, it slow your process. It is time. Reduce the time to market in these kind of things. And as I told you before, data used in artificial intelligence is often big and complex. So it is not also attractive to apply security there. It is challenging. You need to have good experience, good skills to do that. So these are also a couple of things or drivers behind why security is important. But the most important thing, and that is here again, not only for machine learning, but in general, but for machine learning, it's become more important, is you need to do it risk-based. So especially if you are in the finance sector, be aware, and you are using machine learning, then please take measures to check and to, in your whole process, to have it in place before the hackers can steal your money. For safety or mission-critical applications is very important because life of people is dependent on this kind of applications. If you are using machine learning, also here you need to take measures. The aerospace, railway, legal documentation, these are things where you need to apply these kind of things. You cannot do it because you have a big risk if you have some attacks in this area. Of course, if you are developing an application what is used for fun or for something, maybe you can say, okay, I take the risk, I put it on the market, and if something happens, I will solve it. But if you are working for this kind of product applications, then you cannot, let's say, avoid this kind of investment to get your product right the first time. Machine learning is also part of the whole development process. So it is not only the techniques that I show you, especially in the papers, but it has to do also with the complete development process. And here you can see a kind of life cycle where you see let's say, when you get the information, data sources, then you have data preparation, where you do the pre-processing, training the data, and then testing the data. After that, you have a working model with good performance, and then you want to deploy that. So for that, in all these steps, you need to take some measures for model building and model extraction, model deployments and model updates, for example, but also real-time model security. And so I will explain you give you some couple of scenarios that can help you, if you can use that. So for example, for model building and model extraction, you can use some libraries like Python hashlib in such a way that you can use hashing in your data in such a way that it cannot be easily accessible by hackers. That improve a little bit the robustness of your software, machine learning based software in such a way that it's not easy to do that. And this is just an example what you can use within TensorFlow. Another one is what you can do for example, especially for updates, that you cannot just update your libraries or some part of your product without passwords. So double authentication, for example, that you need to have in such a way that not everyone can access easily or hack and change something And after that, you see that you have some open doors in your application. So this is just a standard thing, what I think is not only for machine learning, but especially in machine learning, in case of safety or security, you need to have it in place for updates and this kind of things. So also in real-time model security, we saw yesterday monitoring, for example. You need to monitor in real time your models and check the performance, especially also related to machine learning. And here you can also use some encryptions like Pi crypto that can help you to avoid and do that. So in this slide, I show you the problem and also some example of solution that you can use. And here is this one. So the next one, of the next area is what I want to explain, and is that also from, because machine learning is new, depend on relative what is new, but a couple of standardizations are not yet in place with respect to security for machine learning. We have a lot of standards like OWASP for standard software, but they don't include yet a machine learning aspect. And that is the same for a lot of standards like the NIST, for example. But we see now that a couple of companies are including this kind of standards and including also the countermeasures that can be used. And one of them is indeed the NIST. They have now including also machine learning security. So we see also Microsoft already includes artificial intelligence security in the system development lifecycle. The NIST 8269, for example, they included, but also the BI-MEL standard. And I will explain that in the next slide here, just to show you. I will not go in detail, but I put the references here in the slides. If you want, I can share with you the slides and the links. But you can see here, for example, a couple of things that has to do with machine learning security measures that is explained in this kind of standard. The first one here. The second one is also the NIST. They also include a lot of explanation about what is machine learning security and what are the countermeasures and how you can implement that in your development process. And the same for the BI-ML. They include especially some best practices that you can use for machine learning. As I told you before, this has nothing to do only with machine learning, but in general, there's for security, because when you develop your model, you need to deploy it, and then you are using the standard software development process and practices. So for that, you have also what is the NIST, for example, are focusing on these 5 things. So the 5. So here they are doing identification, protecting, detecting, responding, and recovering. That is also a very good approach that you can follow if you are in your teams are security assurance guys. They are using this kind of approaches, so you can reuse that also. You as a machine learning expert within the team, you can learn from these approaches. The other one is what they call the SIA model, where they have the triangle with availability, integrity, confidentiality. Alex yesterday also explained this by where you can see that the focus is on people, process, and technology. Because even if we have the technology and we have the right processes, it is about awareness. It is about people. If the people are not aware about the risks and the value of this, they will not apply it. So it is also about process, and that is the reason that the SIA model is also very important. And I think, as I told you, if you have people that are taking care of the quality of the process, but also the product, they are also working with this kind of approach. And you as machine learning developer, it's good to also to have basic understanding of these approaches. I will skip this. It was explained yesterday, but it has to do with confidentiality, integrity, and accessibility. And I will focus more on the focus areas that has to do with culture, process, and technology. And as I told you, security does not start or end with one party. It is a group of teamwork. So everyone should involved. For example, if the team, if only the deployment team is aware about security, but you as machine learning or artificial intelligence specialist is not involved in the big picture, yeah, the whole chain is not secure. So every open door that you leave in your model or for your data can affect and can lower the performance or the correct working of. So it is a teamwork, it is a mindset, it is a culture. So everyone should be involved, especially if you have risks for your company or for a product or for a service that you are providing. So awareness and mindset is important. And also, as part of the mindset, what we see for the DevOps or for agile teams, they are moving to DevSecOps, but also for machine learning, we are moving to more ML ops, where also machine learning part is involved in that combination of collaboration with the operations and the developments and the quality. So though the ML ops try also to include that mindset, that culture in such a way that's also not DevSecOps, but also ML DevOps is involved and in such a way that everyone is part of the journey. And what you see is that if you have that, you can take a lot of things that is applied now for security for, especially from the DevSecOps mindset. You have, for example, threat modeling. So if you have someone who is doing threat modeling for your product, also that part of machine learning should be involved. You need also to do some threat modeling for your data gathering, for your data updating, this kind of thing. That should be also included. Security by design. I will show that in the next slide, for example. Security by design, the mindset is that you include all the security things in the process from scratch. You don't wait until the problem is happening and then you are trying to solve, then it is too late. So you need also for the machine learning part include this kind of measures. Security reviews, static code analysis, dynamic code analysis, auto abuse use cases, evidence-based security. So you have a lot of measures, and for all these measures also the machine learning part should be involved and in such a way that the whole team is important. This is just to explain you the security by design and what I mentioned by putting a lot of measures. So for security here, what you see is that if you want to have security in place, you need to take measures from the beginning, because if something happens, you don't have time to correct. But if you have it in the design, then you already have some measures that can easily help you to correct fast. For example, if you have a bug in your live product that has to do with security, you can easily, based on the good work that you do in the design, easily fix and solve. So here you can see a couple of things. Here you need also to involve the machine learning part. Also what they call the surface attack analysis, it is good to include there also all the things that has to do with data collections, data updating, this kind of things. That's also the part of machine learning is involved. So these are a couple of techniques of measures that are used in the standard security DevSecOps, but also should be involved in machine learning. Also, one thing is if you look to the code, what we most time generate or develop for machine learning is maybe not big, but we are using this kind of libraries, and these libraries are very big, very complex, and that is also a kind of attractive area for hackers. They can build in these libraries of tools, of framework that we are using, backdoors of open doors for hacking your product later. So be aware about that and check the libraries, the frameworks you are using before you are using that. Is there any vulnerability in these products before you are using that? That is one. Also, one of the measures that you can take is for example, if you are using Python, you have Python security code best practice. And one of the things that is here, you have a couple of them, but you have, for example, reviewing your dependency licensing, but keep it, when you are updating this library, you need to check the vulnerability for every version you are using. Just to give you an idea about that. This is a list of the example of vulnerability for TensorFlow. It is, of course, a little bit old. I think most of them are solved, but this is just to give you an idea of that indeed this kind of libraries of frameworks we are using for developing our machine learning have vulnerabilities, and the attackers are continually trying to build backdoors in this kind of libraries. Even if there is no problem with your code of your model in the libraries, they can put something that can open doors for them later in the process. So this is actually, but I want just to give you a takeaway. As I told you, awareness is very important. Beside all the techniques I show you of the best practice, the awareness is the most important. Someone within the team or your team should have a clear understanding of the risks and that can be faced in your product. So awareness is very important, and it's good that you are here to hear this kind of things. Also, what can help you, I mentioned in my presentation a lot of links to best practice, guidance, and standards. It's good to take a look to that and try to integrate that slowly in your process in such a way, especially when you are developing a product that has to do with finance, privacy, mission critical things. So please take a look to this kind of standards and do it risk-based. And try to also put some checks in your data, but also in production to check that if you are updating the data or if you are updating your model again, all the things are checked. And stay a step behind, because the hackers, what they are doing, they are continually improving the way of developing new ways to open doors. So we also need to be aware about that and continually learn new things and step behind. That's it. So thank you very much for your time, and I am very happy to answer your question. If you have any questions.
I have one question regarding security and deployment. Like, how can the security breach happen when you deploy your model? If you deploy it not on a device, but on a server.
Yes.
Do you have examples of that? Like, how can they access the models?
I will repeat the question for the colleagues online. So the question is, how can the hackers attack your model when you're deploying it? That is the question. Yeah, it has to do with not only for machine learning, but only when you deploy a standard application, you need to take measures, and there's a lot of measures for that. You need to use, depending on you're deploying that in the cloud or in your own. In the cloud, of course, the cloud company should take care for updating all the libraries and this kind of thing. So you will rely on that. But suppose you have it on your on-premise and you don't have a big team that has, then the risk is higher. Just you need to have in place best practice, and especially if you have a risky product, you have it in. You need to take the measures for deployment. It's not only for the deployment, but also in deployment you need to. There is a lot of measures that you can do to improve the yeah, the security of your product. Is that a little bit what you are?
No, but say for example use some tools like Jenkins or like is there a known breach in their security or where does the deployment problem come? I mean, is it on Microsoft Azure or like what are the known problems there?
Yeah, okay, I understand what your question. In general, you need to have, one of the things for security, you need to have an overview about all the libraries you are using, or all the frameworks. If you are using Jenkins, one of the actions that you need to do, if you have a new version of, you are starting with using Jenkins to check the vulnerability known by Jenkins. If there is one that is high risk for you, and you are developing a risky product, then an alarm should be there that, okay, we cannot use this version of Jenkins. We need to have the fix before we are deploying. If you are using another library, TensorFlow, for example, we saw a list, and you need to check that. So that is one of the best practices. You need to check your libraries with respect to known vulnerabilities. And for medical device, what I know, before you are using the software, there is a risk assessment about, okay, this is the list of libraries, this is the list of applications, and all of them should be green before we can use it, because we have to do this with life of people. We cannot use a library what is coming from a company that have open doors. So, and that is not only for deployments, but also for updating, for even your EDA. You cannot, in some companies, an EDA you need to have a risk assessment about the EDA you are using. For example, the TensorFlow, it is very big, very complex, and on the background they are using a lot of libraries, open source, and that is make it complex. But yeah, if you apply in the best practice and you integrate security in your process, then that should be enough. You're welcome. I will check if there is any question here. No. Any other question?
Maybe I have one more. So about data hacks on images. It's maybe a bit straightforward how you do that, but you also said that it's possible to like hack linear regression models or like regression models, and they're mostly on tabular data. So how could tabular data be hacked, except if someone has like access directly to your data, but in like real life scenarios?
Yeah, for example, if indeed, if the hacker has access in the data, they can manipulate the data. But maybe that is not your question. Your question is more when it is deployed. For example, if by interacting with your model via APIs or by using that, they can try to understand how your model is working. And if they have, for example, information about which library you are using, which algorithms you are using, they can do reverse engineering. And based on that, they can find, okay, if we use this kind of data now, we know how the model is working. Based on the reverse engineering, they can find some open doors. I have not concrete examples, but take a look in that paper that I mentioned, and also for that you can get some examples that maybe can help you to understand how this is working. Okay, if there is no questions anymore, I want to thank you very much. And if you have any questions later, don't hesitate to contact me. I am more happy to share the information I have, the slides, and discuss. I am also learning from the interaction with people. So thank you again.